there, Okuma fans. Charlie with the Gossager Applications staff. We are going to go into Advanced One Touch in this series. We'll have a bunch of these videos. By the end of the run, we should have an entire playlist that'll just be on Advanced One Touch, AOT, IGF, whatever you want to call it. There's been several incarnations of this program assist software, and you can find it resident on an awful lot of Okuma turning centers over the years. I'm using the PC version of Advanced One Touch. You see that right in front of you. And it really is almost identical to what you have on the machine. So we're going to break this series into a bunch of little snippets. This one is going to be number 1, and we are going to start with how to configure our Advanced One Touch software so that we can have the computer do an awful lot of the work for us. Once we get really good at Advanced One Touch, all we need to do is describe our part, and the machine will recommend tools, feeds and speeds, cut parameters, everything that we can think of, including ordering of tools. It's awesome stuff. But we need to start by investing a little time into our software. Just like every other CAM software in the world, you can run this without setting any modal parameters, any defaults, any preferences. But if you take a little time and do that up front, you're going to save yourself a world of hassle as you start going down the road. And instead of having to get in there and tell it, I'm going to use this tool and it's going to do this type of cut. No. Let the software figure it out for you. So I'm using the PC AOT. You see it right behind you right in front of you, behind you. Wow, hey, who am I to judge on how you sit at your computer desk? I'm using the PC version. Sitting there, and your machine is going to behave exactly the same if you've got this installed on the machine. First thing to do, of course, is to go into your program operations screen, and then if you've got a P200 or P300 or P500, it'll be a tab in the upper left-hand corner to get to the IGF software. Once you do that, it will start looking like what you see here. And so we normally, if we were just programming, we would touch new file, but we're going to configure the software to punch a code that we like to see. So I'm going to use the black arrow over key you see right there, change the values of these guys, and these are all of our defaults. Now I'm going to breeze through a couple of them because, yeah, you know what, this is for you guys to explore and figure out, but I want you to know that they're there. The first one, the recess data set, really all this is doing is allowing you to define recesses that can be auto-programmed into the software. You have 4 of them, and we can tell it, exactly how much to undercut if we're trying to do a relief. That's the first one. We have the same thing for center drilling and chamfering. We can give it a specific criteria for what we want to do in terms of center drilling or spot drilling. First one that is really important for us is this material data setting. Now, just like any good CAM, pronunciation today. Yeah, it's Labor Day. My tongue isn't working. So just like every good CAM system, we can tell it what material we're using. We can tell the software what material we're using, and it'll recommend specific feeds and speeds for us based on what we've told the machine we prefer. Depends on our insert grade or what kind of tools we're using. Are we using inexpensive carbide, or are we going for the top of the line stuff? Yeah, that sort of thing. And these guys that you see in there, those are the factory settings. And we could adjust those as we wish. Hey, okay, 4140, yeah. If we were to get in here, we could edit the cutting speeds and feeds for OD turning, ID turning, that kind of stuff. There's our feed rate and our default cut depth. So we can modify that so that 4140 matches our tooling. But you notice that there are certain things that they don't have on here. 2024 is really cool, but we only do about 10% 2024 in my machine shop, which we're going to call Pocket Charlie Engineering. How's that? We do more 6061 than anything else. So, you know, I could either modify 2024, but then I wouldn't have it. Why don't we make a new one? If I come down here and I click into one of the blank columns, my copy item comes available. And by tapping on that, I get a little pop-up window, and I'll just tell it I want to copy over 2024. It comes down here. Now I could edit that puppy dog and call it 6061. And then get in here and modify each of my feeds and speeds. Oh, let's do 1875 surface footage. 12 looks cool. Now, this is something you're going to see throughout these customizations. Cut depth 079. Well, seems like a pretty arbitrary number. Well, the factory default is going to be in metric. But as soon as I switch my machine over to the imperial units that I'm using, it just converted these cut depths for me. So if I were to convert back to millimeters, you'd notice that that would be a spot-on round number. But since I'm running an imperial, it frustrates me to see an oddball number. So hey, let's just go ahead and change that to something that I prefer. Oh yeah. Some nice round number. Let's go, yeah, there you go, and facing inside, yeah, there we go. And I can just go through each of these and edit each one, make it what I want to see, and there's a whole myriad of different cuttings. I usually do the first, the primaries, but things that I don't necessarily do all the time, like mill boring. I've got a turning center. Why would I use a boring head? Anyway, you get the point. This is a good thing to sit down and march through and change to your heart's content. We've now created a 6061 for our machine. So let's close that puppy dog down and move over to parameters. Now this is the one that I want to spend the bulk of our time talking about today. When I touch the parameter key, I get a whole bunch of different fields, and I'm going to start with the dimension parameter and edit that puppy dog. Here's where things start to get perfectly clear. OD clearance, this is the position a tool is going to come to by default before, say, a roughing cut. It's just the positioning. And 320, no. And ID clearance, yeah. Now, if you've already used your advanced one touch, you probably already realize that you can override these when you're programming a tool. You can say, okay, you're going to 320 above the OD. No, I'm going to override it. But by doing this now, you'll never have to do that again unless you're doing something custom. So we just made those all nice round numbers. I'm going to skip a whole bunch of these guys because, hey, all right, they are presets. They are what the machine is going to offer you in terms of, okay, dimension shift, la-di-da-di-da. We're set to 0 on all of those, but feel free to customize those to your heart's content. A couple of clearances down here. Normally I would go through and round those all off just so that they make perfect sense to us, but I'm not going to make you guys sit through 3 hours worth of this stuff. I'm going to skip forward to number 40 and 41, the tool index position in X and Z. This is that home move prior to a tool change. And yeah, if I were programming by hand, I'd be using a nice round number so that I would be able to tell at a glance that, yep, this is my home move. And I always use the same number. I generally, if the machine is small enough, I'll use X30 and Z10. No need to get the Z way far out of the way. So let's just go ahead and make that my default right here. I'm going to say X30 and Z10. There. Now it's going to offer me that as I'm programming, and we'll get to see that when we get to the more distant videos where we're actually putting a tool into material. Now I'm going to skip forward again down to the 70 series, where you'll see that there is all of my work transfer fields here. If I've got a twin spindle machine, I can give it defaults as to, you know, hey, where's my parts catcher, or where's my feed rate? Yeah, I can make these all modal so that in the future when I'm doing a transfer from left to right or right to left, I just say, hey, yeah, work pickup, where's your work 0? That's 0. Fine. Choomp, choomp. Everything else is done. So please feel free to dig through these guys just like you did the other ones and see if there's anything else that tickles your fancy. But right now, that's as far as I need to go on that particular page. So I'm going to OK this guy and jump over to the next one, integer parameters, and edit that puppy dog. Now this is going to be default max spindle speed. There's some numbers in here, but we're going to get to some cool stuff in a minute. It's default to the machine maximum. Well, I got a 3-jaw chuck on there, so yeah, no, I'm not going to allow the thing to do the maximum spindle speed for the machine. As I scroll down, we've got the same for a sub spindle. We've got some gearing selections. Now I have some Word documents that are, yeah, so cool to play around with. Airblow code to do work transfer. Do I want to have the work transfer include the M codes to turn on the left and right spindle air blasts? I can either say yes or no and make that a preferential statement. Now I don't have 2 turrets on this machine, so I'm going to ignore that guy, but here is a nice one that I'm going to take some time to explain. Lap sequence name output. Now we all know sequences in the machine, letter N and then a number. Whether you know this or not, now you will. Okuma does not limit us to numbers when it comes to names. You can have N035 or NLAP1. Hey, all right, that's cool. That's we can throw some letters in there. I use things like NTAP, NTXR, meaning N transfer. So if I name my individual block with a word instead of just numbers, makes it easier for me to do a restart. Well, Okuma knows that you may want to use this, and so what they give us is the opportunity to have N numbers on individual lines, and we're going to see that a little further down in this, this parameter setting. But they will, if I choose to right here, they will make sure that they include letters in the lap sequence. So our roughing, our G85 can cycle, instead of saying N101 for the start of my lap cycle, my lathe automatic programming, it'll say NLAP1, NLAP2. So that way, if you want to restart there, super easy, super easy. And then we'll change this guy over to Synchro Tap, and we will skip down a little more until we find some more interesting stuff. If your machine that's equipped with AOT that you're configuring is a Multus, either a B or a U machine, you can insert the tool change macro number in here, M323, M423, or M321, up to you. If we have that sort of machine, we can also command the TC output and the G code, which one you use in G20, G21 to get us to the home position. But since we're just working on a turret lathe, we're going to skip all of that stuff and jump down to number 81, sequence number increment in process. That means I'm going to put N numbers on each line if specified. And how do you want the software to punch it out? N1, N2, N3, or in my case, N10, N20, N30. I prefer that because then I can stick stuff in the middle if I choose and, you know, skip to it if necessary. But yeah, okay, your preference. We can also specify whether or not we're putting spaces in the program. I generally leave it to 1 space because, doggone it, this thing has 43 gigabytes of program storage. I'm not worried about spaces, and it makes it easier for me to read. Let's jump down to the next one, tool offset cancel output. If you're just using a standard 2-axis lathe, I don't have to cancel the tool output. That means that if I'm using tool 1, the last line of code in my block is going to be T0100 to cancel the tool offset output. It's not necessary if you have a 2-axis lathe, but if you've got a 3-axis or multi-spindle with Y-axis, you need to cancel the tool offset if you've shifted your Y in order to do any turning. Now, this does require that you have the Okuma off-center turning option, but it's super handy. Sometimes we get the gang tools that have 2 parallel stick tools, and I will shift in Y to use the first one on that station. I'll shift in Y to use the second one on that station. But when I'm done, I have to cancel the tool offset and then tell the machine to move back to Y0. Because if I don't, and I was using this Y0 for tool number 1, I ran off to home and I indexed to the next tool and bring tool 2 back in, it will still be respecting the offset from the first tool. So I gotta cancel it. There's another parameter that we're going to come to in just a second that ties in with that. So let's scroll down a little more, and before we get to that, we're going to finish this block, which is, hey, do you want an M1 at the end of every block or every tool? Heck yes, I do. Give me that. And we could force modal M codes, and then we came down and saw, okay, we got a parts catcher. If you do have a parts catcher, you can put in the M code here for each individual command, retract, advance, put them right in there. There we've got our milling synchro tap. I'm going to leave that. And then down to 116, sequence number output in NC program process. Do you want N numbers on every line? Do you not want N numbers on every line? It's still going to use the sequence name in my lap cycle due to that parameter that I set further up. But yeah, okay, go ahead and give me the N numbers. I can shut them off if I want to, but no need to. This is a really cute one right here. Work coordinate number setting, either omissible or not omissible. Ever try to do a restart on a twin spindle lathe? I just want to scroll to the middle of the program and I want to start at this tool without using number search or tool restart. But the first line of that tool is not G140 or G141, so as soon as I mash the green button, I get an alarm. Work coordinate, nothing. Well, if I were to switch this guy to not omissible, it's going to add a G140 or G141 to the beginning of every tool. So now I can just, in automatic mode, scroll down to the place where I want to start. Make sure your cursor is on the G140 for that tool, and mash the green button. You're off and running. That's a cool one. Skipping down to the, about the 151 mark. Here I have additional coolant M codes. If you have a high pressure external pump, let's say an MP Systems, and you're using the spare M codes for turning it on and or adjusting pressure, you can add those codes right here so that when I'm programming, as you'll see in a future video, we can just flip over to the detail setting and tell it, hey, I want to use high pressure on this tool, and it will look here and say, oh, okay, high pressure on M code is M101, and the off code is M102. Hey, I also have some additionals like what's my pressure 3, and that is also off with M102. My pressure 4, 104, and off with M102, so forth and so on. If you're using the Okuma high pressure cycles, M174, but yeah, you get the point. There's 5 of them on here, so you can customize them to your heart's content. Okay, now I skipped all the way down to 230 because when I was talking about the tool offset cancel, I mentioned that, okay, we have to cancel that offset if we were using Y0, but just canceling the tool offset is not enough. I have to then tell the machine with the offset canceled to go back to Y0. If you don't have the off-center turning option, then this doesn't mean a hill of beans to you. But in my case, I do. So I'm going to highlight the Y output with tool offset cancel, and I have a choice. I can either output it only for milling tools, or in my case, since I have the option, I'm going to hit straight output. Now the last line of code before a tool change is going to be G0 X30 Z10 T0100 Y0. So it's going to make all that motion all at once, cancel the tool offset, deliver the turret right to where it belongs, and I get a clean tool change. Booyah! I believe that's it for this particular page. There's a couple for CAS. You know what? If you've got a Multus, give me a shout. We'll show you some of the additional funds on there. And you know, the rest of these are pretty cool, but we're not going to dwell on them. These are percentages of feed rates that we can use for specific cuts. We have each process parameter. This allows me to specify whether or not I'm using G96 or G97, what kind of retract and approach. Do I want to do a dog leg, X or Z then X, or Z and X at the same time on each one of those, spindle rotation. Kind of cool. Then we have each material cutting parameter where I get to specify some more. Like, hey, in my aluminum 6061 with a carbide drill, do I want pecking for carbide? Heck no, I don't. Anyway, there are multiple pages of this guy, so feel free to experiment. And same thing for mill. Bar material preparation. This is how I can customize how I'm feeding bars. Am I using a bar feeder? Am I using a puller? Am I... there you go. There's all my M codes that I might have the machine configured to use. So that's this entire page is all about parts catcher, bar advance, bar puller, all of the happy stuff. And the last one is a machining sequence parameter. Now let's not even pay attention to this right now. We'll give you a little overview on why we're not going to try to customize this. We're going to wait until we get a little further in the video process, because what this is, it's our auto decide, and we don't even know what auto decide is yet, do we? What that is, I just make a graphic on the screen of the entire part, and I click a single button, and the machine, the computer, goes through and says, okay, well, I got this feature to make and this feature to make. I got this tool, it's this material, I got that. It does all the programming for you. Writes the whole darn thing. Well, here is how we're going to tell it our preference for which kind of processes to do first. And we just move them around in this list so that the machine will understand when I do that one-touch program everything. It'll say, well, Charlie likes to do his drilling first, and then he does OD face roughing, yeah, that kind of stuff. Just in case you were curious, I can move things around just like so. Hey, I like to do my OD face roughing and then do my drilling. Oh, you know what? I want to do my drilling after I do my longitudinal roughing. So, boom, I can just move them back and forth with those. We will do that a little bit later, but there we go. Okay, close. Now, I just did that in about, well, after editing, this video is probably going to be 15 minutes long, but you could easily spend a couple of hours customizing those to exactly what you want. It could be even more if you do it the right way, which to my way of thinking is to have a sample program over here, program it, punch out NC code, G code, and look at it and see what you like and don't like. When you find something you don't like, you come over to the parameter and you say, well, okay, I'm going to modify that, then you punch it out again. Well, this is a time-consuming process, and oh my gosh, once I get it perfect, what do I do? There's nothing down here that says backup parameters. What happens if, I'm using the PC AOT. What if I get a new PC and have to reload this software? Oh my gosh, I got to do it all over again. And I did it 2 years ago. I don't even remember what all I did. Yeah, they don't have a backup, but Charlie's got your back on this. I went through my hard drive and I found where where the file is that stores all of these defaults, and here they are listed for you right here. For your AOT PC, the one I have, the folder is called Data L Advance with the name of my machine on it, and then I'm looking for this file. Don't pay attention to the first section, that's the machine. And then .pbu is the file extension I'm looking for. If you're using from your machine tool, you would go to the Windows page. That's Control and Cancel if you've never done that. Hit those two buttons at the same time and you'll get the Windows Start menu, navigate to your D drive, find the folder that's called pbu-dat, and you'll see a file name that looks pbu.dat. The LRKU30, that remains constant. That's going to be the name of the file no matter what your machine configuration, but these last digits will change depending on which version you're using. So let me show you how I do this backup on the AOT PC, and you can just apply that to a machine should you choose to. So let's get rid of this little thing here. So I'm going to open up my File Explorer. I'm navigate to the C drive, my One Touch Advance, and now from my cheat sheet I see that the folder that I need is called Data L_ADV. There it is. And then I picked the machine that I was currently working on. In this case it was the LB3000 MYW. I opened that guy up, and there, right there, is LB3000 Type 2 MYW, the serial number, the model number, .pbu. That's my bad boy right there. That's got all my my defaults. So if I simply right click on that puppy dog and copy it, and I run it over to some place where I won't lose it, in my case I'm doing the desktop, boom, there we go. Now I've got a permanent backup. If you're doing this on the actual machine, I suggest you probably save it to a USB drive so that you can bring it back over, and that way if you have a mechanical or a hardware malfunction on your machine, hey, all right, once I reload AOT, I stick my my USB drive back in there and undo this. How do I, in this event, how do I bring these back in? So it's just a reversal of the process. I'll go to my location where I've got the file hidden or being used right here, and I will copy him, bring him over to the C drive, One Touch Advance, Data L Advance, find my machine, right click and paste it, overwriting the existing file. Wow, oh, that's slick. That's going to save you all kinds of hassle, I hope. So thank you for putting up with me for the last 20 minutes. Again, this is just number 1 in the series, so once you're ready to start programming, look for number 2, and hope to see you out there in the field someday. All right, have a good one.